Okay, let's have the solution to example 19 on right on determinacy and stability. Classify the following structures as determinate or indeterminate, and stable or unstable. If indeterminate and stable, specify the degree of indeterminacy. If unstable, explain or draw the collapsible figure. So this is the first figure. This is a beam. We have continuous beams here. So if we look at the situation, there will be no movement along the horizontal because if you apply a force, there will be constraints or there will be horizontal components of reactions that will prevent moving along the horizontal. So let's now, how about vertical? If you put a load here, it will transmit vertical load here, but there is vertical constraint here, so it will not move. It will not also rotate. Rotation is prevented also because of the available constraint. So let's now counting the number of reactions per joint. So here there are 3, 2, so 5, here 1, 6, then here 3, so that would be 9. And we can have free body diagram here, one part, another free body diagram for this member, then another free body diagram of this member. Since the criterion is R plus or R equals 3n, R9 is equal to 3 times number of free body diagrams, then this beam is stable and determinate, statically stable and determinate. So there are 3 there, 2, 1, 3, and there are 3 free body diagrams. So R equals 3 times n, 3 times 3. So we say that it is statically stable and determinate. For the second problem, this is a truss. By just looking at the top two members, there are two members here. If a vertical load is applied at this joint, it will collapse by the collapsible configuration shown. But that is unstable because there should be no uh, three hinges and one is unsupported, especially this middle hinge. It will collapse downward, so it will rotate downward. This one will rotate clockwise, this one will rotate counterclockwise. So this will be the collapsible configuration. Then for number 3, we have to count for the external reaction. Seemingly it has horizontal constraint and vertical constraint, and also for rotation. In fact, there are 4 unknown reactions, then external reactions. Then for the number of bars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then for the webs or interior members, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 28 bars plus 4 reactions, so 32. And joints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 32 is equal to 2J. The criterion is R plus bar equals 2J. If that is satisfied and the truss is both internally and externally stable, then we say that this truss is statically determinate and stable. So R is 4, bar is 28, and J is 16. So 4 plus 28 equals 2 times 16. So therefore, the truss is statically stable and determinate. Then this is a frame. Then the criterion is if R plus 3 times bars is equal to 3 times joints plus number of conditions, then we say that uh, the frame is statically stable and determinate. So first for reactions, 3 here, 3, 2, so 8 plus 3, 11. 11 for bars, this is 1 bar, 2, 3, 4, 5, 6. So 11 plus 3 times 6 is 29. Then for the joints, 1, 2, 1, 2, 3, 4, 5, 6, 7, 7 joints. And there is one condition here because there are two members here. The number of conditions is equal to number of meeting members minus 1. So there are two meeting members minus 1. So we have one condition here. So 1, 2, 3, 4, 5, 6, 6 bars. And plus 11 conditions. So 11 plus 3 times 6, 29. Joints 7, 3, 4, 5, 6, 7. 21 plus 1, 22. So 29 is greater than 22. So this frame is statically stable and indeterminate to the 29 minus 22, so 7th degree. So R is 11, bar 6, condition 1, so R plus 3 bars compared to 3J plus C, so 11 plus 3 times 6 greater than 3 times 7 plus 1. That's why it is statically stable and indeterminate to the 7th degree. So that's it for this uh, stability and determinacy of structures.